Alright, so Module 1, Lesson 3 is about finding unit rates when we have fractions. Okay? So, part of the way, remember there's two ways we can find unit rates. One of the ways is using it as a fraction that we've been working on. And another way is putting it into a ratio box. Does everybody remember that? Okay? So that's what we're going to talk about today. I'm not going to make you write it for now for the sake of time, is I can compute unit rates associated with ratios of fractions. The word compute means to calculate or to find. So if you see that word, that's what it means, and you're going to see that word. Okay? I want to practice for a second putting a fraction on top of a fraction in your calculator. And what I mean by that is putting, say, 2/3 over 1/5 in your calculator, because we're going to need to know how to do that. So, everybody grab your calculators. You're going to put in the fraction button. Right? Everybody click the fraction button. You see your blinking fraction up there. There should be a blinking box in the numerator up top. Do you see that? I want a fraction of 2/3 in my numerator. So I'm going to have to hit the fraction button again. It should put a fraction on the top. Do you see that? Alright, put in 2/3. So 2 and then down to 3. So we should have 2/3 in the numerator. Now jump down to the denominator. You've got to put 1/5. Well, that's a fraction, so guess what you're going to have to put in again? Another fraction. And then you type in and make it 1/5. Alright? Hit enter. What do we get?
I got 10/3. I got 10/3.
You didn't do it right. If you're getting 2/15, you're not punching in correctly. Alright, so then you gotta hit the fraction button again. Now we gotta move down to the denominator. I'll need another one. Hit the fraction button again. So you should have gotten 2/10 as your answer. Okay? Alright, so remember that skill because we might need it later on. Alright, so I can compute ratios that involve fractions. It's basically what we're doing. We're basically calculating unit rates when we have fractions. Well, our vocabulary word today is unit rate. Now, we've had this vocabulary word before. We had it in lesson 1. And then we shortened it and made notes on it. Okay? Take 30 seconds with your families to flip back to the first page. Don't lose your spot where you're at. You just open up to the very front and you find where it says unit rate and how we shortened it. 30 seconds, y'all talk about it, how you can shorten that definition and what it means. Go.
It's a ratio. It's a ratio.
Alright, so who thinks they could tell me what unit rate means based off of your notes from the first page? Part. Number. Okay. So what Clark was saying is when you have a ratio, in a ratio, when the second number is 1. Okay? When you have a ratio and that second number is 1. Remember I said unit rate was one of our buzzwords. When you have a ratio, you're comparing X value to Y value. Dogs to cats. Purple to gold. Pancakes to waffles. Okay? You're comparing two separate things. When you're comparing those two things, you're comparing it X to 1. So if I'm comparing waffles to pancakes, I'm asking myself, how many waffles to 1 pancake? If I'm comparing cats to dogs, how many cats when there's 1 dog? This is what a unit rate is. Okay? I would take my highlighter, right here, do you see it says how to find a unit rate? That's important. I would highlight that. How to find a unit rate. We've talked about there's 2 ways. The first way is a ratio box, which is described right here in these steps. What did we say the second way is? Ratio box or, KK, what were you going to say? Simplify the fraction. You got 2 options to pick from. A lot of people tend to lean towards ratio boxes because that's what you used last year. And guys, you're going to use them in high school. The high school teachers ask us to use ratio boxes because they use them in high school. Learn it now and it makes your future a lot easier. So the first step is to create a ratio box. But this is missing a very important piece. What should you do with your ratio boxes on the outside? Label them. That's important. What are the 2 things we're comparing? Waffles to pancakes. Well, then my label should be waffles over pancakes. Boys to girls. Boys, girls. Miles to hours. Miles over hours. Money per hour. Money over hour. Okay? So when I set up my ratio box, I should have my label, 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 label on both sides. Whatever the first value is, the first value has to be it on the other side. Whatever the second value is, has to be the second value on the other side. For a unit rate, you're always going to be looking for this box when the second value is 1. And then this column right here, the first column, that's where you plug in the information that you have. If we're talking about cats to dogs, you have 20 cats when you have 5 dogs. So you'd put 20 over 5. So right here where it says set the denominator of the second ratio to 1, that's what we did right here. After that, we cross multiply. What do we do after you cross multiply? Divide, and then you have your answer. Those are your steps. So if you on your test, it says, find the unit rate, you're going to flip through, go, oh, I know we took notes on that, and bam, right here it tells you how to do it. So let's look at example number 1. Put this into practice. A recipe says to use 2/3 cup of milk to make 4/5 servings of pudding. Y'all like pudding? Chocolate pudding, vanilla pudding. Anybody like banana pudding? I like some banana pudding. How many cups of milk are in 1 serving? Okay, so we're solving something here. We're trying to find 1 serving. What are the 2 things we're comparing? Because that's what a ratio is. It's a comparison of 2 things. Jada, what do you talk about? Cups of milk to servings of pudding, right? So guess what the labels of our ratio box should be? What should the labels of our ratio box? Milk and servings. What are the 2 things you're comparing? Milk and servings. So what you're comparing needs to be your labels. So I've got milk to servings. Milk over servings. So when I make my ratio box, I'm going to label that on both sides. Milk to servings. I'm trying to figure out how many cups of milk, I don't know, are in 1 serving. What's going to go in these 2 boxes? What's going to go in this top left box? 2/3. Well, how much milk do I have? What did the problem say? 2/3. How many servings do I have? How do I solve? Cross multiply. Anything times 1 is what? Itself. We shouldn't have to put that in the calculator. 2/3 times 1 is 2/3. Then what do I do? By what? Not 4.5, 4/5. Which gives me 5/6. 5/6 what? What does that 5/6 represent? We have mixed feelings. Which one is it? What was the missing question piece here? X is the missing one. Okay? So we found it. X equals 5/6. Well, what did that represent? That's also why we label it, so we remember what we're looking for. So 5/6 cups of milk per serving. There's our answer. So if I need to make 1 full serving of pudding, how many cups of milk do I need? 5/6 cups of milk. Are we good? Is this bringing back some memories from last year? We should start bringing some memories back. This is what you did last year. All right. Jalen makes limeade using 3/4 cups of water for every 1/5 cup of lime juice. Rennie, it's limeade. I don't know how you say his name. Rennie, I don't know. Our limeade recipe is different. He uses 2/3 cups of water for every 1/6 cup of lime juice. Whose limeade has a weaker flavor? Well, before we answer this, how do we know if something has a weaker flavor? It doesn't taste as sweet. It's not as strong. So what's happened to the mix? Why is it not as strong? You use less sweetener or use what?
Don't use as much.
You haven't used enough flavor, or maybe you've used too much water. Have you ever heard the saying it's watered down? Okay? So like when you have a baby and they're old enough to drink apple juice, you don't give them straight apple juice because you're just feeding them sugar. You give them a little bit of apple juice with a lot of water to water it down so it's not as strong. Okay? So the weaker flavor is going to have more water than the other. Okay? Does that make sense? So to find the weaker flavor, we need to figure out which recipe is using more water. So we need to have the same amount of lime juice. Okay, because we're talking about unit rate, we need to go, okay, if I'm going to pour 1 cup of lime juice in this one and 1 cup of lime juice in this one, how much water are they adding and which one's going to be weaker and which one's going to be stronger? Okay? So part A says to highlight that word, compute. What did we say compute means? To calculate or to find. So if you're ever taking your test or you see it in your homework and you're like, I don't know what compute means, you've got it in your notes. Compute the, what is that? Compute the unit rate. Buzz. There's a buzzword there. I'm going to get me a buzzer and make it somebody's job to buzz it. Okay? Unit rate. When we think unit rate, we need to think x to 1. That second value has to be 1. Of each flavor. So we've got to figure out Jalen's and we've got to figure out Rennie's. Renee, I don't know how we're saying it. Okay? So we got Jalen's first. We want to figure out Jalen's unit rate. So we can do it as a ratio box. What are the two things we're comparing? Cups of water and lime juice. If you don't know, look for the numbers, and then whatever the numbers are talking about, that's your two labels. Cups of water, cups of lime. So for Jalen, we got water over lime. Water over lime. It has to stay constant. It has to stay the same. So we can't flip our labels here. So we're trying to figure out how much water when there's 1 cup of lime. What are we going to fill in these boxes with? All right. How much water? 3/4. How much lime? So when I cross multiply, I get 3/4, right? Because anything times 1 is itself. Divided by 1/5. Do you see how because you remember how a fraction is division? Do y'all remember that? Well, it is. Fraction means division. So this is saying 3/4 divided by 1/5. Last week we talked about how we could simplify using fractions. This is why we can simplify using fractions. Because it's the same thing. So what do we get? I'm just writing it different. What? 15 over 4. Let's convert that. Hit that double arrow. What is it? What do you get when you hit that double arrow? 3 75 hundredths. What does that 3 75 hundredths represent? It's a number, but of what? It's a decimal. Of water. We solved for X, right? Well, what does X represent? Water. So 3 75/100 cups of water. That's Jalen's. Now whose do we have to find? Renee. The R one. Does knowing how to say that name matter when I'm figuring this problem out? No. If you can't figure it out, just skip it, okay? We're doing the same. Water over lime. We're still trying to figure out how much water is there when he adds 1 cup of lime. Well, how much water does he add? 2/3. And when he adds 2/3 cups of water, how much lime does he add? 1/6. So we want to solve for X, so we're going to cross multiply, which is just going to give me what? Divided by 1/6, which gives me 2/3 divided by 1/6 gives you 4. 4 what? 4 cups of water. So who's going to have the weaker flavor? Who's going to have the most water to water it down? Huh? We have 3.75 and we have 4. Which one is more water? Renee has more water. $3.75 or $4? Which one's bigger? $4. So Renee is going to have the weaker. Why is it going to be weaker? Because it has more water. He has more water per lime. If all of y'all do your homework tomorrow or tonight, if everybody has 100 on completion with all their, what's that called? Work shown, then we'll do this as a little experiment to see if it's actually true or not. And we'll test out some limeade. Okay? But that means everybody has to do their homework tonight.
Y'all made lemonade and limeade.
One's made with lemons and one's made with lime. Alright, so y'all can see what I mean by which one's weaker and which one's stronger. Okay? Alright, number 3. Last example, and then I'm going to quit talking. And you're going to start practicing. Okay, number 3. The moon has a weaker gravitational pull than Earth. Did y'all know that? There's more gravity on Earth than there is on the moon, right? Okay? So when objects weigh less on the moon, because gravity is what's pushing you down. For example, Jackson weighs 30 5/6 pounds on the moon and 185 pounds on Earth. While Viola weighs 135 pounds on Earth and 22.5 pounds on the moon. So part A says, show that the relationship between weight on the moon and weight on the earth is proportional. That's a buzzword. Proportional. Buzz. Highlight it. Highlight proportional because that's a buzzword. Well, what does proportional mean? It means that they are equal, equivalent, or equal. We've been testing this out. That's what we did last week. We've been finding their unit rates, their constant rates. Are they the same? Are they not? How did we do that? How did we figure it out? Well, we used them as fractions, or you can put them as in a ratio box. So we've got Jackson versus Viola. So we're measuring, we're comparing two things. What are we comparing? We're comparing Jackson and Viola, but what two things? Weight on the moon versus weight on the earth. So we've got moon over the earth. Because what did they tell us first in the problem? Moon, and then they said earth. So we want moon first, then the earth. Moon, earth. We want to know how much does Jackson weigh if he weighed 1 pound on earth, because we're looking for the unit rate, which is another buzzword. So how much does Jackson weigh on the moon if he lived on the moon? 30 and 5/6. And how much does he actually weigh on the earth? 185 pounds. What am I going to do to solve? Cross multiply. 30 and 5/6 times 1 is going to give me 30 and 5/6. Then what do? Divided by 185, which gives me a beautiful number of 1/6. Okay? In order for it to be equal, what does Viola's unit rate also have to be? 1/6. We want our unit rates to be the same. That's what proportional means. We want it to be the same, equal. So we got to keep it the same. We got to do moon over earth and because we're finding unit rate, there's X goes here, 1 goes there. Then we're going to fill in our spots. How much does Viola weigh on the moon? How much does she weigh on the moon? On the moon. Did you see what they did in that problem? They swapped it. You have to pay attention to that detail. She's 22.5 on the moon. Because think about it. Would it make more sense for her to weigh more on the moon or on the earth? On the earth. So the bigger number should be on the with the earth. Okay. How much does she weigh on earth? 135. We can't just look at the numbers. You gotta look at what the numbers are saying. Okay, how are we gonna solve? Cross multiply and divide it. So 22.5 times 1 is 22.5 divided by 135 gives me 1/6. What does that tell me? If they're equal, what do we call that in math words? Proportional. So right here, you see where it says the constant of proportionality? That's another buzzword. We need to highlight it. And we need to remember that constant of proportionality is K equals Y over X. The second value over the first value. And they even tell us here which one was the second. They say moon over the earth. Well, guess what? Is that the order that we already did it in? Moon over the earth. So what is this 1/6 then? It's the constant of proportionality. We already found it. So what that's saying is, when you go to the moon, it is 1/6 of your weight on the earth. Okay? Let's look at part B. Let X represent what? What does X represent? So that looks like hard to find. Let's make a note about it. X represents Earth. The weight on Earth. Y represents so let's make it easier to read. Y is on the, I have to make little side notes like that, guys, because I'd rather look at that really quick than have to read through a bunch of information. Write an equation for the proportional relationship. There's another of your buzzwords. When I see that, I think Y equals KX. Well, we've already found K. What was K? What does it say loud and proud? 1/6. So because we've already found K, because K was our constant of proportionality and it was 1/6, we can replace or substitute K with 1/6. So all of our equation is just Y equals 1/6 X. It's not rocket science. It's just plug the number in, right? That's the equation. That's all they're asking for. The second part to this says use it to find it is that equation to find the weight of a 25-pound dog on the moon. So the dog is 20 pounds on Earth. How much is it on the moon? Well, look at these little side notes. Which one is the 20 going to replace? The X or the Y? What does 20-pound dog represent? Where's the dog right now? It's asking you to find it on the moon. Where does the dog live? Earth. Okay? So if the dog is 20 pounds on Earth, is that going to go for the X or for the Y? X. So we're going to we're going to substitute the X with 20 pounds so that we can figure out Y, which is how much he is on the moon. So we're going to replace Y, so it's going to be Y, that 1/6 stays, times 20 pounds. So when you plug that into your calculator, Y equals 1/6 times 20. What do you get? 10/3, which will convert to 3 1/3 pounds. So if the dog weighs 20 pounds here on Earth, if we shoot him to the moon, he's going to weigh 3 1/3 pounds. Okay? It can be real light. Like the weight of your binder is what the dog would weigh. Okay. I'm stopping. You're going to do this. You're not doing number 1 though. Okay? I'm going to shorten it a little bit. You're going to do 2 through 4. Solve 2 through 4 on your paper. Go. Do it. It's got to be done because tomorrow I'm going to ask you for your answers for 2 through 4. Do it now. You've got 8 minutes before the bell. Do 2 through 4. Don't do number 1. Do 2 through 4. Not doing this one.